Hi, my name is Manish Gupta, and in this video, I'm going to talk about the AYA model, which is an instruction fine-tuned open access model, multilingual in nature. This paper also won the Best Paper Award at ACL 2024. So let's get started. Why is understanding about AYA model important, right? I mean, of course, it won the ACL 2024 award, Best Paper Award, but it's also important because it addresses multilinguality for instruction tuning. So recent large language models, if you look at them, most of them work for a handful of rich languages, although the world speaks more than 7,000 languages. So so most of these models have been actually trained for English. And then they basically report some results saying that, hey, by the way, because some multilingual data was also mixed in the pre-training data, the model actually shows surprising multilingual abilities. So most of these models have not been trained, keeping multilinguality as the primary motivation. In fact, at this point, when they actually trained the AYA model, around 73% of the popular instruction fine-tuning data sets were primarily English. So in fact, the best multilingual fine-tuning data set is XP3, which basically contains 46 languages, about 81 million samples, of which about 39% are still English. Right? So therefore, to address this gap, this lack of multilingual instruction fine-tuning datasets, Aya came up with the Aya collection of data, which basically comprises of 101 languages, of which 50% plus are actually low-resource languages. You can see the split here. So there are high-resource languages, mid-resource, and low-resource languages. There are examples of languages as well, which you can look up, right? So this data set is basically 203 million samples, of which just 21.5 are English compared to, let's say, XP3, where 39% are English. Right. Now, the interesting part is that on several different kinds of tasks, discriminative, generative, human evaluation, win rate comparison using human as well as GPT kind of models and so on, folks observe that the Aya model is actually better than MT0 and BLOOMZ models, which are popular models of similar size and also address multilinguality. Right? I'll talk about the evaluation in more detail on the next few slides, but the idea is that Aya model is actually one of the best multilingual models covering a large number of languages. From an architecture perspective, the IO model has been pre-trained from basically it has been fine-tuned on MT5 model, and it has the largest MT5 model, which is basically 13 billion parameters in size. It's curated by Cohere for AI, and the model was released in February 2024. Although the overall training data actually is 203 million, but to keep the overall training in check, the training compute and so on, they have a training budget of 25 million samples, which basically means that they sample about 10% of this data. I mean, 10 to 15% of this data, so as to actually train their model. They observed that their initial trained model is not very awesome in terms of offense generation or hate generation or bias and so on, and therefore they actually further do safety context distillation so as to mitigate the safety concerns. And I'll talk about the details about how does it actually improve the model further. Okay, so let's talk about how was the training data for Aya model obtained. So as I talked on the previous slide, the overall training data is 203 million. However, the data which is used for actually training the model is about 25 million. So let's see what all is comprised in this overall training data set. So the training data set consists of three main parts. The template-based training data sets, the yellow part, right? The human annotation-based training data sets, which is basically this blue and the pink part in that senses. And then, the human evaluated data sets, which is basically the blue and the orange part at the bottom. Now, and then there's a translation-based data set, which is basically this pink part. Okay. Now, as you can see, these data sets cover different number of languages. So in fact, the multilingual templates, if I talk about that itself comprises of three different data sets. The XP3X data set, which is basically the cross-lingual public pool of prompts extended data set. The data provenance collection and the Aya collection, the templates part of the Aya collection. The Aya collection actually is a large collection comprising of different parts. In the multilingual templates part, it's basically the template part of the Aya collection. The data provenance collection actually is those publicly available data sets where the source has self-reported commercially permissive licenses. Okay. So these data sets, of course, differ in terms of their overall sizes, the number of languages that they capture, and again, I mean, internally, how many data sets that they're comprised of, right? They also differ in terms of how many high resource, mid resource, or low resource languages they cover. What percent of the data set basically is covered by high resource, mid resource, and low resource languages. Okay. So the blue colored part basically is the human annotated part of the AYA collection. Of course, the pre-training, of course, the instruction fine-tuning data can also be obtained using translation. So therefore, the pink colored part is the translated subset of the AYA collection, which has been actually obtained by using the NLLB, which is basically the No Language Left Behind project, which translated, automatically translated using the NLP models, the English fine-tuning data sets to 101 languages. So these are automatic translations of English fine-tuning data sets to 101 languages. Right? And the last one is the ShareGPT custom data set, which basically is the human annotated prompts from sharegpt.com website, combined with the synthetic English completions from in-house LLMs. So previous models have basically leveraged ShareGPT dataset. However, ChatGPT basically has this terms of use which prohibits people from using the ChatGPT generated completions, and therefore these folks essentially use the English completions from in-house LLMs. So now, overall, this data set is huge, some 200 million plus samples. However, their training budget was basically just 25 million. So to be able to live within this training budget, they actually sampled, 3 different subsets. So these subsets differ in terms of which part, they sample more from. So there are 3 subsets, essentially human annotation heavy subset, translation heavy subset, and template heavy subset. Now, obviously, these subsets basically sample more from the corresponding data sets in the overall AYA collection, right? So in the overall set of things that I mentioned at the top. So for example, the human annotation heavy subset upweights AYA dataset. Translation heavy subset upweights AYA translations and ShareGPT custom, while template heavy upweights the AYA collection X3PX dataset and data provenance collection, right? So that's that. Now, for their overall AYA model, essentially they report the best results using the template heavy data, using the translation heavy data set. Sorry. Okay, so how does the AYA model perform overall? So they basically compare performance across several tasks. So there is a performance comparison with for discriminative tasks. There is a comparison for generative tasks. There is also a comparison using the the multilingual version of the MMLU dataset, and then there is a comparison, for essentially translation tasks, human comparison or GPT-4 based comparison, and then lastly there's also comparison with toxicity, bias, and safety benchmarks. Okay. So the comparison is basically done across multiple baselines like MT0 and BLOOMZ. These are 46 language-based models fine-tuned using XP3 dataset. So, comparing with them may not be fair because this model actually supports 101 languages. So more languages may mean worse accuracy, but they compare with MT0 and BLOOMZ regardless. We also compare with MT0X model, which basically is trained by themselves. So they took the MT0 architecture and trained over, XP3X dataset, which has like 101 languages, so as to make it comparable with 101 languages that the AYA model is also trained on. They also compare with Bactrinex model, which basically supports 52 languages and a Llama 13 billion parameter model. And it's basically fine-tuned on the Bactrinex dataset, which has 3.1 million multilingual pairs of instructions and responses. Lastly, they compare with the Okapi model, which basically supports like 26 different languages and is basically fine-tuned on BLOOMZ 7 billion and Llama 7 billion. So the comparison is made across several discriminative tasks covering co-reference resolution, natural language inference, sentence completion, language understanding, and so on. Generative tasks basically include translation, summarization, question answering, and open-ended generation. So on discriminative tasks, you basically observe that MT0 model is MT0X model, for example, first is actually worse than MT0 model. So as you can see, it is basically worse than MT0 model, right? However, their proposed AYA models are all significantly better compared to the other baselines, especially the translation-based model with the star at the bottom here, right? It's basically significantly better compared to other model in terms of all the discriminative tasks. Now, for the discriminative tasks, of course, the template-based model is actually the best one. However, net, if you look at across all the tasks, you would observe that the translation-based model, translation-heavy model, is the best across most of the tasks. So here are comparisons at the bottom with MMLU, multilingual MMLU benchmark data set. And again, you can observe that the few shot based in context learning kind of prompting with the IA model gives you better results compared to Okapi MT0 or MT0X. For the generative tasks, again, you can observe that the IA model is much better compared to MT0X in terms of both, in terms of all the tasks, translation, summarization, and question answering. And then lastly, when you actually compare IA model with MT0 or MT0X, both GPT-4 and humans agree the translation quality using IA model is much better compared to MT0 or MT0X. Right? So overall, net, the IA models essentially lead to significant improvements in quality for discriminative tasks, MMLU, translation-based tasks, summarization, question answering, and so on, compared to the original MT0 model. Now, from a toxicity, bias, and safety perspective, compared to MT0X, the IA model actually generates less toxic outputs and translates gender slightly more accurately. However, it has more racial bias. Overall, the IA model does lead to significant harmful generations as well. And therefore, what they did was to do safety context distillation of the IA model so as to basically make it more safe. And that reduces harmfulness by about 70%, but then that also leads to a drop of about 2 to 3% in the performance across various tasks. Okay, so in summary, in this video, I talked about the IA model, which is a 13 billion MT5-based model. It supports 101 languages and across multiple benchmarks, discriminative, generative, benchmarks, MMLU, multilingual MMLU, and so on. We observed that it vastly improves over all massively multilingual open source models like MT0, MT0X, Okapi, and so on, across a large number of automatic and human evaluation settings. That's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my search on my homepage. Thank you.